screen? Do you see my screen? Well, I'm just...
Yes, we do. We see
okay.
your screen, Liuba. Thanks.
Thank you. All right. Thank you, everyone, for attending today. So I'm Agota Végső, and I'm originally from Hungary. And as you heard, I'm originally an animator. And quickly, early on in my life, I realized that I'm really interested in sciences, but it was really hard to find a fusion between art and science, and animation offered me this possibility. So I finished my studies as an animator, but I also have a teacher degree. And luckily, when I went to Denmark in 2014, I met with like-minded colleagues. And since then, I'm collaborating with the animation workshop. And since 2017, we actually created an initiative called SciWhy. And during... sorry, just a moment. And during these years, since 2014, we created many science-related animations and lectures. And it's actually also the time since we collaborate with TED Ed. TED Ed is the education initiative of TED Talks. And we are creating short animated lectures about all kinds of sciences to the general public. I mean, mostly young adults, but I have to admit they are really nice lectures. So even all age groups and from different countries are looking at these animated pieces. So what is interesting about SciWhy that we are also constantly working on better communication strategies between the artist and the scientist. And today I would like to talk about this, what is science animation and how we are approaching it with this SciWhy initiative, and how online animation on social media is so crucial at the moment for environmental education. And first I wish to talk about the science animation production from the animation angle. Then I would like to show it from the researchers angle. And we also create these kind of bridge building events like audiovisual communication trainings. And through that, I would like to introduce you how animation can be a great tool to communicate about basically any kind of research and sciences. And I will finish with a case study about a climate-related issue. So at SciWhy, we do these really specific type of animations. They are not longer than 5 minutes. They are in English language and try to grab the essence of certain researches. And we house on the right side of the screen, you can see the list of artists that we are collaborating. And we wish to create this library of animators that research institutions can collaborate with. So we are 3 in this group with my colleague C.S. Sondergaard. I'm in the middle with short hair, and my colleague from Aalborg University, Peter Vistisen. And we have a website called sciwhy.dk. At the moment, it's under construction, so it looks a bit different. But you can see all the visual materials and case studies that we collaborated with scientists in the last years. So we have this initiative since 2017, and we realized through our journey that we wish to concentrate more on climate-related topics. And luckily, TED Ed was a great partner, or is a great partner in this mission. And why is so interesting to do these animations? It's more about how game-changing these visual materials can be. Like nowadays, when we are talking about misleading information, fake news, and after this pandemic, we really understand why is it important that scientists find a way to communicate even about work in progress research. Animation can offer this kind of bite-sized informations in a really well-wrapped visual package that people can check on social media, and it can, it have to compete with all the fake news and misleading information. And we are not just trying to train and help scientists to use new ways of visual tools to find the right visual vessel or communication vessel of their message, but we believe that if we create these really flexible collaborations between animators and scientists, we also create these kind of educational materials. These lectures are also training the viewer, that we are telling the viewer that it's really important to know the information that you see, where it comes from, what is the source, if it's based on just one research, if it's based on several point of views, if it's something that is under construction. We need to think about the online audience as critical thinkers, and we wish to help them to create thoughtful decisions, especially about climate change, which is not a one answer topic. It's a network of different cases, informations. And now that we collaborate with KITME and Climate Fact Checks, we are also working on a project about climate change education for kids. And we really see that cultural differences, economical differences, just communication differences can raise those kind of questions that we need to address when we create online educational materials. I wish to share with you this video clip about the climate-related TED-Eds that we produced in the last 3 years, just to give you an idea what these kind of videos, how these kind of videos can look like before I go how we do the productions. I'm sorry, technical difficulties. Yes, so this is a very specific type of animation that we are doing in collaboration with TED-Ed, and mostly we are working with students, alumni from the animation workshop in Viborg, Denmark, and the scientists that we are collaborating through TED-Ed are from all around the world. And it's really in high focus that it has to be quality made animation, but also that communication is a key during the production. Like everybody has to be really responsive, and TED-Ed puts in high focus checking the facts, making not just the material, the content research-wise accurate, but also ethically, politically correct. They really focus on that these online materials are going out and being able to watch from anyone from around the world, And if we think about that these days, when half of the world's population have internet access, this is a tremendous amount of diverse audiences. So I want to a bit justify why is it important to focus on online science animation, online science communication through social media, because obviously, yeah, these lectures look great. They must be about important topics, but there are numbers that are also prove it. And today I wish to present more the animation industry side, because there's a rich library of academic papers about the effectiveness of animation in education, which is really important. But most of the studies are done in a more laboratory-like circumstances, and they are representing a bit different angle. Like if we regard the literature, there's proof that like from the 80s, comparing to still images, there are differences how animation convey messages. And throughout the years, more and more educational research about animation concentrates on not if animation helps understanding or learning topics, but which animation helps to understand and learn which topic. And I'm highly interested in this part because I believe that during science animation collaboration between a scientist, an institution, an educator, and an artist, a visual storyteller, through the communication, they always find the right way of communicating it, depending on obviously the timeframes, the financial support, and the resources that they have. So year by year, there are more institutions who are putting more effort in communication training for their researchers, and scientists are adopting trendy communication channels, for example, social media channels, and they are finding their own ways to communicate their material. And I'm just talking here about one opportunity when they can collaborate with visual artists if they don't feel like that they want to produce their own visual materials. Because in this case, we can offer a new insight from a visual storyteller, an animation professional who's a master of their own visual communication skills. And with the technology fast evolving, there will be more and more opportunities. And it's not just opportunity, but it's also a need that science needs to feel, and they need to communicate in a way and on the channels that people are consuming their information. And this also gives animation a new path. It's more and more obvious now that it's moving out from simply an entertainment category. There's already this science functional career path for animators and animation film directors. And it involves a special type of production that is really important. That, for example, we are also teaching at art institutions, animation academies, and we wish to contribute with SciVi to this new chapter of science communication. I wish to share with you some research about how people consume their information, especially about climate change, because yeah, I can assume that climate or just science animation is popular and people are watching it, but there's proof, for example, as you can see from the Reuters Institute's digital reports from the last 2 years, also the 2022 report is proving that there's more and more dominance of online information consumption. And on the right side of the screen, you see that it's according to different age groups, how people consume their information or what are their sources for climate change news. And even that television is still dominating. If we count all the other sources, the online news sites from major news organizations specialized outlets covering climate issues, and alternative sources such as social media, posts, blogs. Actually, this is already more in percentage than the source, the television source. And I'm from Europe. Obviously, we all live in our own information bubble. And in Portugal and in Europe generally, there's a different type of device usage as in different parts of the world. And on the left side of the screen, you can see that more and more we human are checking our information and news through smartphones. So it's not anymore, even in Europe, computers. And in certain areas of the world, like in South America, Africa, and Asia, it's getting more and more dominant. These devices are more and more affordable, and Cheap Mobile Net offers this new gateway to reach the internet, to reach any kind of information. And it's actually more and more dominant. And if you look at how people consume actually their news, it's, I think, I don't remember the exact percentage from the Reuters Institute's report, but it's around 80% among young audiences who actually not checking news website directly, but gaining their news through side doors, like reading, seeing a post on social media. And if you regard the overall population, it's also around 70%. So when we create these kind of online animations, we have a proof that it's really important to compete with all the information, all the fake news, all the misleading information on social media that people actually check 80% of the time when they are checking anything online. And besides that social media is really dominant, and we have to take control how scientific information is spread. People still trust scientists the most. So it's should be really in high focus to help scientists, to give scientists the right tools, and to help them to find the core of their messages, of their research, and be able to communicate it. And this diagram is from 2022, but it's even higher in 2023, how much people actually trust scientists, especially after the pandemic. So you can see that it's even from, from 2022 to 2023, it even got a higher percentage, 1%. So I wish to share with you one of my little case studies that I did part of my PhD, because I was curious how major organizations are communicating climate change through animation. And first of all, I checked the Edelman's Barometer and the Reuters Institute reports what people are using to gain primary their news about climate change. And then I created this list. The most popular channels are documentaries, news outlets, internationally acclaimed NGOs, online, non-profit organizations, social media personalities, activists, governmental agencies and organizations, educational channels, and educational institutions. And I selected 3 for each group to look at 21 social media channels to see what kind of animations they are using. It's when you saw the TED movies, they are one type of animated science communication. But regarding the message and the research, we actually can create so many other types that can grab the right communication. I just give you one quick example. Obviously, there can be, for example, interactive and gamified science animations or animated science communications, and certain topics are better matched to reach their target audience through that channel. The problem is still that not all social media channels support interactive and gamified possibilities, more linear communication-led videos. But here you can see that all these organizations that I checked, they all have a website, a YouTube channel, a Facebook channel, Instagram, Twitter, and TikTok, and many other online communication channels. The next graph shows that when I checked these 21 organizations, I checked their websites and YouTube channels because the YouTube channels usually contains all the video material that they are sharing on Facebook, Instagram, TikTok, and the websites contains all the various interactive and gamified possibilities. And from these diverse selection of participants, it's still the most dominant. As you can see, 60% of the animations that I looked at are explainers and education videos, but the richness of the other types shows that we have to keep an eye on what technical possibilities are offering. And when we create education online materials, we have to have an open eye for what the people are looking for and consuming. So there are many information visualizations, 50% of these specific case studies participants, computer-generated simulations, which is really important regarding climate change communication, where simulations can show changes over time, like sea levels, like temperature changes, like economical changes. The next most popular was motion graphics, which helps to communicate with easy animated icons, any processes. Animated commission videos are getting more and more popular, which means that it's more like an advertisement type of usage of animation. So it can go not just online, but even to television and traditional type of media channels. The next popular one is animated short films. That is interesting because it's more to the artistic side of animation usage. Artistic short films that can go to film festivals, but also can be shared online and in television as well. And here the last two ones are animated educational games. Like some games actually even can produce materials and results and data for the research. Like there's a quantum mechanics game which helps the researchers to see how the users are moving quantum atoms, and while playing the games, producing data for the research. And the last one is animated 360 videos. And because of the growing usage of VR goggles, virtual reality goggles, and cheaper and cheaper devices, the 360 videos are also getting a really dominant role. And YouTube even launched a few years ago its 360 channel. So these VR videos are actually also available on 2D devices. So now I wish to talk a bit more about the exact science production. I know that today the audience, you are from different fields, from different age groups, different professions, but I would like to show you a bit more how in detail an animation is produced, because when we collaborate with educators, we still meet certain problems because technology is so well developed, so modern. Sometimes you feel that some people regard animation as magic. You just write in something into the computer and it just spits out the right animation. To get the right animation, it's really important to get the specific details. And in our science visualization productions, we are working with mostly 2D digital animators. As you saw it at the TED movies, they are mostly two-dimensional digital animations. And we chose this technique because it's really fast to produce. And even that we need to change something, it's still easier at any stage. But I would like to tell you in the next few minutes why is it important to have constant communication and engagement when you collaborate with a visual artist. And this is also showing the pitfalls that we have to pay high attention to not to lose a production. Because when we collaborate with certain research institutions, we hear back that they already tried collaborating with visual artists, but there was a misunderstanding. They couldn't really find the right language to communicate with each other. And with our audiovisual science communication trainings, we try to train both animators and scientists to ask the right question, to find the right language for each production, because we are all different. Everybody communicates differently. We all have our own niche. We all have our own terminologies, not just because a science community has their own terminologies and the artists. It's each and every one of us as a human being have different expressions, and we have to really pay attention how we communicate our messages. So the science animation collaboration's main objective is that the scientist, the educator, and the animator are equal partners in the production of, for example, a video lecture. It's really important because in the industry, when we talk about animation productions, especially creating advertisements, for example, for television, there are these habits that there's a material, created package, a brief, and goes to the artist, and they just digest what they got. And there's like 3 times when they can receive feedback and they can change. This is different with the research visualization at our SciVi initiative, because we are still discovering what are the best ways to communicate, to bridge build this science animated science communication field. And it requires high focus on communicating with each other. So we fusion design, information, and entertainment. And our main objective is finding the right visual vessel for the communicating material. So this is the angle from the animator. Oh, I see a raised hand. Is that a question?
I think you can continue with the presentation. We'll take questions at the end.
Also, it was a really strange name.
I know. So we can take questions at the end where our audience can type in the questions to the chat bot, and I can ask you the questions myself.
All right. So basically, when we do animations, we discussed the following topics. What is the purpose of the animation? What is the technique that we can do, afford, is available? What is the format? Format can be a short animation, can be a longer lecture, can be some fragments that the educator or researcher can use in a presentation, can be illustrations that it's possible to include to grant application, and what is the target audience. Later, when I talk about the trainings, I will discuss it a bit in more details. And what is the distribution plan? So as an animator, I'm interested to know all these details, how that researcher wish to communicate their message to whom and which channel. Is it peer-to-peer communication? Is it for social media? Is it for an inside presentation in the research institution? These all make tremendous differences. And when an animator builds a production, these are usually stages. And I signified in red the layout animatic, because that is almost the last moment when we can make major changes. So first we receive a script. Then while digesting the script and creating the storyboard, the first design materials are get shared with the educators, and the storyboard contains not final designs, but more like on white paper, black drawings, or really schematized elements of the content. And the storyboard is a sequence of still frames next to each other with a description showing what happens in the animation later. And we put these still images next to each other, we get the animatic, which is already moving. And the layout animatic is the stage when everything is at the right place. It kind of moves, but it more like shows what will happen. So this is the stage when we can change anything. And usually when we work with work on any kind of research, we include the voiceover, the narration, if there is already in this stage. And this is the moment before the animation, before really the time-consuming precision work, that we can still change things. And I wish to show you a little clip to actually help you to visualize what does it mean to be in this layout animatic stage before the animation. Here you can see on my screen, it's divided into 4 little screens, and these are the stages of the same animation. In the left top corner, you see the black and white draft version of the lecture. In the top right corner, you see when it already has some more finished designs, and the left down corner has already a bit more fine-tuning in animation and backgrounds, and the last one is the finished animation. So between these 4 stages of animation, actually almost the same amount of time spent. But the funny thing is, when you look at it, I just remove the sound. If you look at it in movement, the big change is between the first one and the second one. And after that, it's colorful, there are movements, but the main content is not changing. This lecture is about dust, and actually these frames are showing how particles and different materials get degraded. And it just signifies that when an educator or researcher collaborates with an animator, after the layout animatic stage, after the draft stage, actually the time is spent mostly to fine-tune, to finish the design. And that's why, especially at the beginning of a project, it's so important to communicate clearly and patiently. I showed you these stages. After that, so layout animatic, there's animation, cleanup, composition, putting together the sound, the background, the animation. Retake means if there's some correction needed, because obviously our main focus creating any science animation is that it has to be accurate, it has to be valid, it has to represent that research in the right way. So we are really flexible still at the last stages, because we can't publish something that is not fully approved by the collaborators. And throughout our journey creating science animation, we realized that there's a huge parallelism between research. I show on the left side of the screen steps of the quantitative research process, and the right side the steps of the animation production. And I think it's also one of the reasons why animators and scientists can collaborate so well, because they understand through communication, through discussions, how similar the steps are in a research process and in the animation creation process. And in this case, there's more empathy and understanding to collaborate better together. We also realized that there are some differences when we create science animation, if it's about science, technology, engineering, mathematics. Those animations are more analytical. The pace of the animation, the movements are slower. There are more descriptive scenes with less movement, but more explanation. And the scientific information needs usually more correction and discussing how is it the best communicated in the narration or visualizing. When we talk about more social scientific topics like anthropology, economics, psychology, social sciences, and history, for example, it's more narrative. We need more character animation, and the movement, since it contains more human characters, it's actually more dynamic. And even that, obviously, there must be a high accuracy in the scientific information, we deal with more ethical discussions and questions throughout the production. So this is the point of view of an animator. And when we started to create these science communication trainings, we realized that we can't just communicate these stages, how an animation is made, when we create these trainings for example, PhD students. So here is a really basic communication diagram. And we obviously start with really the basics when we start a communication training, because science animation follows the same steps. It's really important who communicates what in which channel, like how animation is meant to use, to whom. And we already have to think about not just the distribution, but what effect we wish to generate with that communication. So while we were talking with scientists, we realized that we need a new approach to analyze how we can create this bridge during the audiovisual science communication between the artist and the scientist. So obviously, the first step is to understand who is the science communicator, because it's throughout the history, it changed a lot. And nowadays, it's actually anybody who communicates science to a target audience. It can be the scientist itself, it can be a journalist specialized to communicate sciences, it can be even the visual artist, and it can be a combination of these. But there's a science communicator, and when we create any kind of visual communication, it has to be clear who communicates that information. And we first look at, obviously, the classical channels, the classical science outreach, when we start to deal with what is the best communication with animation for that certain topics. And there are these classical activities like talking at conferences, creating posters, doing workshops, or any other demonstrations. And there are animation possibilities to include in this kind of science communication outreaches to emphasize the understanding of the scientific topic. Also, when we create any kind of scientific animation, it can be used as an illustration, as a still image as well. For example, in articles, essays, or books, And these are also giving a possibility to include into other online communication channels like blogs, websites, posting the videos on the websites or on social media, and many others that we actually don't know even yet, but growing online. So why is it important to use, for example, any kind of moving images, dynamic visualization? I think it's hardly, it's a challenge of science communication, for example, to talk about something that is in progress. And animation can bridge this gap. Obviously, while doing research, it's really hard to communicate about anything when you don't have yet results. It's when we create these science communication trainings, we put it in high focus that we have the scientists to communicate about something that is in progress. And animation, since it can show movement, it can show processes, is really good to match to communicate anything which is not yet final, but is really important to make the online audience, the public, knows about what is under development and how certain fields like communicating about climate change is developing. What are the potential new results that will come up, even that we don't have results yet. So it's really important to reach the audience, to call for action, especially about climate education, and to open doors to get, for example, more funding for research. It's just a funny gift that shows that it's so important to state the right amount of communication. So we also include a really basic pitch training that, for example, here, it's a scene from Princess Bride, a movie from the 80s. And this character is stating really essentially what is he about to do. So he has a polite greeting, he tells who is he gives a context, and then he tells what's going to happen. And this is actually really the type of cluster that we are using when we create any kind of science animation or audio-visual communication. We have to include all these points that are on the screen. Who is communicating? What is the message? Why we are communicating it right now, right here? What is the purpose? Who is the target audience? When? And what is the format distribution? And just looking at these elements, when we focus on the target audience for whom, it already creates huge differences in the created science animation, because it's a totally different visual language that we need to use when we communicate peer-to-peer from same field colleagues or from colleagues to different scientific fields, or if it's a grant application to the scientific community. We need different kind of dramaturgy and emphasizing different elements when this science animation is about gaining more funding, or when it's about teaching. Different age groups, different level of knowledge of the students require different communication type in science animation. And obviously there's the basic general public communication. And in our work with the SciVine initiative, actually, we mostly create online public communication. While working with educators and scientists, my colleague Peter Vistisen came out with a different kind of discussion scale, and he created these kind of scales to actually ask the questions from the scientists and the educators what they wish to communicate with animation. And you remember at the beginning, when I started to talk about science animation production, I stated these stages, not stages, sorry, these objectives that we have to discuss when we create science animation. What is the purpose, the topic, the technique, the distribution plan. And we decided or we realized that these are too dry. It's so untangible when we talk about these things with an educator. So Peter took a different approach and found out these continuums that are better with communicating about sciences. If it's to novice or expert audiences, peer-to-peer or public, do you want your audience to think, or you want to communicate type of detail? Is it subjective or objective approach? Do you want to use something which is more high fidelity as a really well done 3D animation, or more as a sketchy type? Is it an abstract or a concrete visualization? Do you want your audience to be active as they play in a gamified animation, or more passive? Do you represent your own point of view, or is it a pluralistic? These questions actually help way much more to create a communication between an artist and a scientist. Here's a tiny exercise that I wish you to think about after my webinar, just to find the core or an essence of your research. That what is your narrative? What do you want to communicate? What is your objective? Why you are the one who needs to communicate this research and message? And who are your target group, and how do you want to reach it? And actually, there are these really essential sentences that we can use to practice this kind of communication and help you to collaborate with visual artists later. I want to teach something because it is important that I communicate this. I will communicate to your target audience, and I will reach out them by certain tools. For example, I want to teach scientists to communicate better about their research because it's important that they reach the right audiences. And I will communicate that they can use science animation to publish video lectures on social media. And I will reach out these researchers by writing emails to science institutions to include these science communication trainings. These are just some tips to present, be simple, tell a story, be clear about what you're communicating, be certain about your details, and know and connect your audience while talking to them. Be unique and special. Actually, we all have a special message. You are always the right person to communicate your research. You just have to find the way to put it out there in the best way. And now I wish to close with a little video clip about one of our case studies that we did on one of our PhD courses at Aalborg University in 2021. And it all started with an abstract from Aurelia, one of the participants, who's actually researching the environmental effects of seaweed on the shores. And we paired her. We made a match between her and the visual artist called Cosimo Miorelli. And Cosimo made some sketches. And through the stages that I introduced you in my presentation, Aurelia and Cosimo discussed the topic and created an animation. And I would like to show you this animation because it's a bit different than the TEDx, because Cosimo is actually illustrator. But this is also animation, frame by frame, changing communication about something related to environment. So this is the final animation.
Is this just smelly waste rotting on the beach? Before it was washed ashore, macroalgae or seaweed was out at sea, anchored to the seabed at depths not too deep, not too shallow, where light still reaches the bottom. It was creating an environment for other species to flourish. There are three main groups of algae: red, green, and brown. All algae, as they grow, take in nutrients directly from their surroundings and store them within their tissue, helping reduce the concentration of nutrients in the water. At the same time, swaying within the water column, algae provide a hiding spot for various types of marine organisms. They create a shelter for fish eggs and a nursery for juvenile fish, such as herring, which are caught by fishers and end up on our table. Algae caught in the swell of a storm are torn off the seabed and brought to the beach. They tell us about the rich life and vibrant ecosystem underwater. Here, as they decompose, they are a food source for small organisms and provide a feeding ground for birds. Because decomposing algae release nutrients back into the environment, they are also an eco-friendly fertilizer for crops. Next time you're at the beach and step on some algae, remember, they contribute to our livelihoods in many ways and are not just stinky waste.
Thank you very much. I just put on a little conclusion on the last slide that animation is a great collaboration partner to reach the AIM online audiences. It's obviously time and energy investment for both the artist and the researcher, and needs dedication, patience, and flexibility, but it's worth, as you can see. Thank you very much.
Thank you so much, Agata. I think that was really educative, and that information, I think, is something quite new to the Sri Lankan audience, because this is not an area that we mainly focus on. But again, it is really important that we do, because we also need to communicate the messages, the scientific research that has already been done in the country in a more effective way to the general public. And the talk you just did, I think, helped a lot more people understand how exactly to get about it and do it successfully. Thank you so much.
Thank you. Well, I guess we are open for questions. If anybody has any curiosity or doubt, I'm here to answer.
If you can stop sharing the screen, we can get on the gallery mode and wait.
Yes. Well, just to bridge the time between we receive questions, I can meanwhile talk a bit about what we are working on with KitMe right now, with the climate fact checks. We are, so KidMe told us about their program to go to schools and create these climate awareness days and making certain activities with the students from various age groups in Sri Lanka. And we had an idea when we met this year in February at the 7th International Conference about Climate Change in Colombo, that we would like to create small bite-sized animations that can be used in these awareness days about not just about what is climate change, but what specific challenges the people has in Sri Lanka, and not just raising the problem, but finish each animation with a solution on a small scale and some questions that are generating thoughts and curiosity in the students to dig deeper, to ask questions, to ask the right questions from the teachers or search the right information online. And this is all about using animation to create critical thinkers, especially when we think about kids and young adults.
Yeah, and also on our end, I think the main initiative and the main objective of doing something like this is because the Sri Lankan education system does have climate change included in its content, but the effectiveness and the way it is delivered to students may not be as impactful, and we thought maybe we could try doing something different and see how these students respond to it. And if they do respond well, maybe we can look into continuing this further and delivering the message in a better way. So does anyone have any questions right through the talk? Right.
Yes, Mateus?
Shall I unmute him?
I guess.
Yeah.
Hi.
You can ask your question.
Hi, good morning, good afternoon. Thank you so much, Agota, for your presentation. Very nice. I really enjoy it. I'm curious about how you think animations could be applied to the context of scientific journals, for example, that nowadays works more with graphics and texts, for example. Thank you.
Thank you for your question. Yeah, that's a really interesting topic. When I started my PhD 2 years ago, actually, one of my first small case study was about why is it still that everything is archived as a written format, as papers, even that there's so many videos and great visual materials used. And obviously, it has two answers. One is that technology is giving us more and more opportunities, that scientific journals on the online platform has already the possibility to have more dynamic visualizations, illustrations. There are more and more articles that can include interactive diagrams or little videos. And I think just thinking about how the publication formats are also changing, and there's this new format called pictorial, which is like 80% pictures and images. Soon the online articles will have more and more, can take more and more requests of this kind of video-based illustrations. I just have high hopes, and I really try to do more and more this kind of trainings and show how animation can be a new possibility to convey dynamic messages. And on the other hand, we still have to, that's the other answer, that we still have the challenge that the platforms and the plugins are changing. And for example, there are many articles from 5 years ago that the links expire. Even that certain researchers have on their websites places to, I don't know, store the videos or the interactive materials. It can be diminished with time. Also, just with regard Flash Player from 2021, it's not anymore supported. So all the GIF animations that might have been embedded into websites are not working, and those visuals are not anymore available. So it's still really tricky. So we are working on to give a bigger variety to use videos in publications and online journals. But at the same time, we need to think about that with time, it might not be available, and create more libraries. Like ACM has the video library, but it don't have a good search engine. It's not that well used yet, but we have to work on these solutions and talk about it. And that's really one way to give more space. Did I answer to your question, Mateusz?
Oh, I think he needs to be.
Yeah.
Oh yeah, thank you. I have my microphone mute. Sorry.
Don't worry.
Yeah, thank you. That's it. It's a big challenge. I think mainly because the platforms and the size of these media files. So yeah, I'm curious to see what's gonna happen. Yeah. Thank you.
Thank you.
We also have a question sent by Dinesh Balsri. And the question is, animation storytelling is a simple visual language that can be understood by all types of audiences. His question here is that while giving a scientific explanation, it should be understandable. It should be, understandable by all types of people from all walks of life. So how do you deal with that? How do you make sure that all the audience, like everybody from different knowledge levels, understand this animation with scientific information? And also, isn't it sometimes difficult to understand when too many scientific explanations are given?
Too many scientific explanations.
Like in the animation, if you add too much scientific, like for example, you spoke
thank you for the question, Dinesh. Yeah, it's a really good question because it's definitely a challenge of science animation. As I emphasized, different target audiences need different languages. And for example, during our science communication training, we are working on to analyze these different ways of communication. So when we talk about animated storytelling, we try to avoid to use simple, because actually it's not simplifying your research, it's finding the core, the essence, and that helps you to find synonyms to communicate to different, for example, age groups. Just let's regard different age groups. You would use different words if you communicate to a 5-year-old, to elementary school student, to a graduate student, or to your fellow researcher. But if you can identify the core, it also helps you to wrap it in a way that if you just make one video, if you're aware that you have terminology, you apparently has to repeat that terminology also in a different explanation or using metaphors. And in that sense, different knowledge levels understand the same video. When I talk about sci-fi, I talk about science visualization, I immediately admit that what is that shortcut standing for. When I talk about, for example, VR, I immediately repeat it's virtual reality. It's a digitalized animated recreation of real life view. So I immediately kind of explain what I'm talking about. It can be one way, but definitely when we create science animation, we have to be clear about who we are communicating, and it has to be kind of obvious when the audience sit down and start to watch it. It can be also the title, who tells more. We can also label it in the description, or already the design gives us more information if it's a really scientific representation of a certain, I don't know, quantum mechanical problem, or it's more to grab the core for kids and make them get interested. Yeah, it's really challenging, but we try to work on it through training and get more and more information. What are the challenges with this storytelling? When too many scientific explanations are given, I'm not really, can you rephrase, can you put this question in a different form that I understand it better?
So for example, I think what Dinesh is saying is that when, let me unmute him, I think he can ask the question himself.
Yeah, maybe that's best.
Yeah.
Hi, Dinesh.
Yeah, okay. What I mean, if we add more scientific explanations in that some kind of difficulty, right? And some some teenagers can't be understand what actually the meaning in. I mean, when we add more scientific explanation in animation films, like.
See, well, we definitely have to deal with, for example, with cognitive load. So when we create these science animations, I usually work with a team who's already experienced, but yeah, when we started to work, they were learning it on the way, but they have really clear visual understanding what can be too much for the visual eye. And we follow these rules of visual narratives that, for example, at one time, one thing is moving on the screen. If it's something too difficult, we put labels. If it's really complex, we put labels, and the narration also explains. So if you mean by many scientific explanation, too much science in one video, like it can be overwhelming for the audience, we definitely have visual solutions to deal with this kind of overload. And yeah, we have to watch, for example, show the videos to certain audiences to get feedback. What can be, for example, too much, when it's too much scientific data or explanation. And for example, this is also why the TED-Ed videos are most likely not longer than 5 minutes, because even that it's really fine-tuned, the right amount of information in the right complexity, after 5 minutes, your brain is just full. I can't expect that it gets into the short-term than the long-term memory in the same way. If it, yeah, it's just after 5 minutes too long. And for example, another great tactic that TED-Ed also has, after each video on their website, they have a tiny questionnaire. And that immediately asks questions what you understood from the lectures. And by this recall process, it's more likely to get into the long-term memory and create those traces of knowledge that helps to get not too much scientific explanation competing. Did I answer your question, Dinesh?
Yeah, I got it.
Thank you so much.
I think we have another question. I'll unmute Silila Sandavela.
Hi, Silila.
Hi, Agatha. It's a pleasure to meet you again once after the conference. So it's very interesting topic as well as a great informative session. And I enjoyed your lecture really well, and as well as your marvelous sense of humor. So I have one question. So when the animation go to the public, do you think that its color combination affects to the audience acceptance? So if yes, what are the tricks you used when choosing colors to the animations?
Thank you so much for the question, Silila. Yeah, the color combination, if it affects the audience. definitely there's an effect. Here I also have two answers, because one is related to the cultural understanding of colors, and the other one is really technical. Because, for example, when we think about these lectures, we can't really guarantee who's watching from which type of device, what kind of quality, is it pixelated, is it well color coded. So when we create the lectures, we have to make sure that even in bad circumstances, for example, contrast is strong enough to understand certain figures, forms, characters. Also, if the monitors or the screens are differently calibrated to colors, we have to make sure it's not irritating, and also not to use too pastel colors that maybe some lines are not visible. So this is one objective that we are following. On the other hand, still the technical answer that we are working with visual artists, and obviously their mastery, their knowledge about aesthetics is really important, because that gives them a special toolkit and knowledge also about what shape and color combinations are easy for the eye, not overwhelming, not too much visual information, because especially we have to deal with a lot of cognitive information. So yeah, this is really important to pay attention on. And culturally, for example, especially with topics about history and literature, we highly focus on accuracy, ethically and historically. And that's why each collaboration is different, because we already faced this kind of challenges when we collaborated with educators from different countries, that we have different understanding about, for example, clothing, colors as signs. Is red is a warning sign, or in, for example, Japan, it's a sign of happiness and luck. And for example, in one of the lectures about a historical piece, we used reference images for the clothing of the people in that era, and we thought it's quite accurate. But the educator helped us to find a better match for nowadays, which allows people to relate more to the characters from their own country, even that the reference photos were correct. So it's always really important to keep track on the color coding, on the color palette, and discuss it, because I might not aware what, for example, Sri Lankan color coding is, and I'm highly paying attention on what Kipni is saying for us when we collaborate. Did I answer your question, Silila?
Yes, Agata, because this question raised, because Sri Lanka is normally have very different cultures. Hope you can best deal with them, and good luck for your future works, and hope to meet you again. So thank you for the interesting lecture.
Thank you so much for your question.
Thank you. So I have one last question based on your animation. So from what I understood, I think so the researcher and the artist works together, but in a sense, the researcher has to have a creative thinking capacity, and also the artist needs to understand the research work done to simplify it, so that the artist needs, again, a bit of scientific knowledge as well. So when it comes to creating a production, especially in terms of STEM education, how is the response from your audience, or even the target audience, compared to maybe social science or different topics? Like, does science education get the attention, the same attention compared to other animations which are similar but different topics?
Yeah, great question. Yeah, first of all, these collaborations are a bit different than industrial just advertisement creation, because we ask already the artists to have the willingness to study the topic. So when we pair an artist with a topic, with an educator, we already ask them their interest, because they have to read sometimes articles. They have to even, there was one topic about animal genitalia, and the artist had to read a whole book because she needed to be also expert on the visualizations on those special organs. And I didn't mention, but for example, collaborating with TED-Ed, when we get the script and the voiceover, actually before that, the script editor and the TED-Ed team already spent months with the researcher to fine-tune that research and to convey it to a 5-minute narration, finding the essence to that right public communication. And yeah, we create these lectures, and obviously, for example, we follow the view numbers. So between STEM and social sciences, actually, there's a huge difference, because some of our lectures created for TED-Ed has views like millions, like 8-9 million people watched Greek mythology ones about Arachne, about also Nordic mythology character Thor. And these are uncomparable, for example, to a STEM view, which can be a few 100,000. But it's different, like it's a different cognitive effort that we need from the audience. And especially in the pandemic, the numbers, view numbers, like skyrocketed, because kids were at home, and parents sometimes just put them into the to watch video lectures to get entertained with good entertainment, with effective entertainment. And these historical literature lectures from literature got really popular. But for example, one lecture about colon cancer, it's a really hard topic. Obviously not the topic that a kid would watch, like, oh, what's on about colon cancer research today. But the feedback from the scientists, they found it really useful to use this really light lectures. I mean, the language is really light, it's really easy to screen it to the general public. They found it really useful in their scanning process to talk about this seriously dangerous sickness with the endangered age groups. And in this case, the views are really different, but the value is uncomparable. And it's really hard to keep track of the effectiveness, but these feedbacks from the educators helping us to believe that even that the views are not that much for certain harder topics or STEM-related topics, but the existence of the lectures are really crucial and vital, because they communicate in a really digestible way, really complex topics in a valid visual communication form.
Yeah, I think I got the answer. So I think we've reached the end of the webinar now. It's 5:30, and is there anyone else with questions? If
you can
not,
also contact me later at my email address, agotavekso@gmail.com, if you have any further questions, or ask Climate Fact Checks to contact us.
Yeah, if you have any questions, or if you would like to also, learn more about animations for science communication or climate change education, you can always, come to us, or even, and then we can direct you towards her. So one last time, I would like to thank you so much for taking the time and speaking at the webinar today. I think we all found it very useful and very interesting. And this is an area not much opportunity is created at the moment in our country, but I think there is a lot of potential here. So it's important that we create more awareness among the young crowd and also the general public about these possibilities of communicating the knowledge that we collect scientifically. So thank you so much, Agatha. One more time. We'll see you.
Thank you
soon.
very much also for inviting me, and I'm really glad that I could talk about my research and science animation to you today.
Okay, so I'll say good evening to everyone. So if you have any questions, like we mentioned, please contact us on our social media pages, or just drop us a message on our chat bot. We can get back to you. And also stay tuned for our next webinar from the next month. Until then, bye-bye to everyone.
Bye-bye.
Bye.
Have a nice day. Ciao.
You too. Bye.